Question number 3 is based on periodic table. We want to identify X, Y, Z prior to do this question. So let's see. So we want to draw the periodic table before starting to write answers for this question. The atomic number of X. X, you can see there are 1, 2, 3, 4. 4 valency electrons. Then if it has now 4 valence electrons, the atom should be in fourth group. Atom should be in fourth group. We can get that information from the periodic table since the group number is similar to the number of valence electrons. As well as it is mentioned that the atomic number is below 10. So we can write the X is carbon. The period to which X belong in this table. X belong, the carbon is X. X belong to the second period. Second period. So this is period number. The group to which Z belong in the periodic table. So Z, when it comes to Z has 1, 2, 3, 4, 5, 6, 7. 7 valency electrons. It means Z belongs to the group 7 since its atomic number is greater than 10. That is chlorine. Chlorine, 7th group. The molecular formula of the compound formed by combination of X and Y. X is carbon, Z is chlorine. So by combining this, we want to consider the valency numbers of carbon and chlorine. The valency of carbon is 4 and chlorine valency is 1. Then when we exchanging valencies of these, we get CCl4. If not, we can write, since the carbon is X and chlorine is Z, XZ4. So molecular formula of this compound is XZ4. If not, you can write carbon tetrachloride. The type of the chemical bond existing between X and Y. Y is the atomic number is 1. Y valence electron is 1. Since it has 1 electrons, it belongs to the group 1 and we identify that is hydrogen. So X and Y, in between X and Y, it means this is CH4, methane. So this has covalent bonds. Covalent bonds. And the type of chemical bonds existing between Z and Y, Z is chlorine and Y is hydrogen. So this is HCl, that is also covalent bonds. Next, the chemical formula of Z when it exists in free state. Z is a gas, so chlorine exists in molecular version. It means Cl2. So if you can't see the periodic table, in this periodic table, blue color numbers that show group numbers give information about number of valence electrons. And the red color numbers, those are period numbers. Those numbers give information about number of energy levels. And the green color numbers down there are very useful for writing chemical formula. Those are called valences. So then if we consider the electronic configuration of carbon, its carbon atomic number of carbon is 6, then electronic configuration is 2, 4. So these are the information we can find from the periodic table. This has 2 energy level. This is 1 and this is another one. It means this belongs to the second period of the periodic table. So that's why carbon belongs to the second period. So that's why I told period number gives information about number of energy levels. Then the number of valence electrons are 4. So carbon belongs to the group 4. It means carbon belongs to the group 4. So by remembering that, let's move to the next part of the question, part B. The elements in third period of the periodic table are given below with their atomic numbers. Elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. In this graphs 1 and 2 below, mark the position belonging in this element Let's move to the part B. The elements in the third period of the periodic table are given below within their atomic numbers. Then you can see that there are elements from sodium to argon. In the graphs 1 and 2 below, mark as the position belonging to the element silicon. Element silicon atomic number is 14, and electronic negativity, when we consider electronic negativity of silicon, is higher than aluminium. So it should be in a place like this. And if we consider crystallization energy of silicon, it is higher than magnesium. So it should be in a place like this. Of the elements in the third period, select the elements in third period, select the element fitting each of the following statement and write its chemical symbol in the blank. The element forming chloride with M2 plus ions. For forming 2 plus ions, 2 electrons should be released. So to remove 2 electrons, the valency electrons, there should be 2 valence electrons. Then group 2 elements have 2 valence electrons. Let's see, the group 2 element here is magnesium. The electronic configuration is 282 since its atomic number is 12. So after releasing these outmost shell electrons, magnesium become magnesium 2 plus. So the answer is magnesium. The element forming an amphoteric oxide. Amphoteric oxides are the oxides both have acidic and basic nature. Aluminium is the answer. The element existing as a monoatomic gas. The noble gases behave like monoatomic gases. So argon is the answer. Next one. Which element in third period reacts fast with cold water? That is sodium. Sodium reacts with water vigorously by forming sodium hydroxide and hydrogen gas. So this equation should be balanced. So for balancing, I will do like this. And the formation of sodium hydroxide is a strong base. And to identify whether a base has formed, we can add phenolphthalein. Then phenolphthalein turns into pink in the presence of base. As well as we can add litmus papers. Basically, red litmus turns into blue in the presence of bases. Red litmus turns into blue. Given below is an incomplete chemical equation for the reaction between magnesium metal and steam. Fill in the blanks. Since this is a steam, H2O is in a gaseous state and magnesium oxide forms. So that's enough for now. Thank you.